let you know. All right, here we go. You are about to be square rootified.
It's not a bad thing.
No, it's a great thing.
All right. Under square roots. Yes. Whoa, is somebody there? What'd that mean? You're presenting
It's Jake Washington.
Okay. Here's the deal.
Wait,
Okay, if you remember, ladies and gentlemen, when you see square roots, see square roots like this, okay, there are a very well, there's an infinite amount of ones that work out, but in the real world, there's very few ones that work out. You know, remember what square root says? What same number times itself gives you 36? What is it? 6. Okay. Square root of 36, we call those perfect squares. There's very few actual perfect squares. Okay. You know, we could have the square root of 49, which is 7. Okay. We're going to look at the ones that don't work out today. Okay, because the ones that work out are nice, neat, and even, but the ones that don't work out kind of throw us for a little bit of a loop. For example, the square root of 20. Okay, the square root of 20 doesn't work out. Believe it or not, in our world, it's called an irrational number because it doesn't work out to anything but a repeating decimal. But there are ways that we can simplify
tip of the hat. You have gotten all of the attendance done. Thank you.
There is a way to simplify that. First of all, as with everything in math, you should look at that and you should say, well, the square root of 20, you should be able to tell me what number it's close to, or what numbers it's between. What number is it between, Lex? It's between 4 and 5, because the square root of 16 is the square root of 25. Okay, but there is a way to simplify it in math. We always try to simplify it, and that would be this. Here's how you go about it. And I will tell you at the beginning of this, don't get lazy on me. As much as I know how much lazy you're not, please don't do it now, okay? And this is how you simplify square roots. The first thing you need to do is you need to prime factorize them. At some point in your life, you won't have to do this, but right now you will, okay? In other words, what number times what number gives me 20? And by the way, you need to draw the radical signs with these because the square root of 20 is the same thing as the square root of 2 times the square root of 10. Right? 2 times 10 is 20. Square root of 2 is a prime number, so you can stop with that. But the square root of 10 is the square root of 2 times the square root of 5. Am I right? Am I right? Are you with me?
Yeah.
Okay. So let me rewrite those in order. I have now prime factorized it. It is the square root of 2 times the square root of 2 times the square root of 5. That all gives me the square root of 20. Okay. Here's step number 2. If you see doubles, you will cross both off and get a non-square root number. What do we call that number? Radicand, I guess it is. You get a non-square root radicand. Bless you. Now, what that simply means is this. If you see identical radicals there, 2 square roots of 2, you cross them both off, and you're left with just whatever is under the radical sign, which is a 2. Which makes sense, ladies and gentlemen. Why? Because the square root of 2 times the square root of 2 is the square root of 4. And guess what the square root of 4 is? It's a normal 2. And you get that. This one does not have a pal, doesn't cross off, so you have to re-multiply it or just put it back there. Okay, so that's your step number 3 is you need to, you need to re-multiply when done. So the square root of 20 simplifies into 2 times the square root of 5. And that is simply it. You don't have to give me decimal equivalents or fractions or any of that sort of stuff. That is that, simplified. James?
What if there's like 3 square roots of 2?
Well, we're getting there. I'm gonna do another one. James says, what happens if this is the case? We got a couple more examples to do. Let's say it is the square root of 24. There is no, 24 is not a perfect square. If you prime factorize 24, you end up with the square root of 2 times the square root of 12, right?
Yes.
The square root of 12 is the square root of 2 times the square root of 6. And the square root of 6 is the square root of 2 times the square root of 3. And James asked this question, well, if you simplify this, let me write it down in order so we can see it. Square root of 2 times the square root of 2 times the square root of 2 times the square root of 3. Following said rules we just talked about, these 2 square roots of 2 go away to give you a normal 2. These 2 don't have any pals or whatever. If you have leftovers, that's where the remultiply part comes in. You have to remultiply those and get the square root of 6. Radicals can be multiplied together. Regular numbers can be multiplied together, but you don't multiply 2 times to get 6 and get the square root of 12 and do that. You just leave it like this. 2 square roots of 6s. How about another one? What if it were 2 the square root of 2,000? Yikes. If you're breaking 2,000 down, what would you break it down? I'm going to say the square root of 20 times the square root of 100. Because that's 3 zeros. The square root of 20 is square root of 4 times the square root of 5. Square root of 100 is square root of 10 times the square root of 10. Square root of 4 is square root of 2 times square root of 2. Square root of 5 already is prime factorized. 10 is square root of 2 times square root of 5. And 10 is the square root of 2 times the square root of 5. Look at all those numbers, isn't that spiffy? So how many 2's do I have? 1, 2, 3, 4. Wait, did I miss one? Yeah, no wait. Did I miss one? No. There's 4 square roots of 2? 1, 2, 3, 4, and then there's 3 square roots of 5, I believe. 1, 2, 3. Right? 1, 2, 3. Crossing off, no, don't see it. Crossing off what I can. This gives me a normal 2. This gives me a normal 2. This gives me a normal 5. This one doesn't have anything crossed off, so it stays 5. And then you have to multiply this. 4 times 5 is 20 square roots of 5. And if I asked you, Lex, since you got it the last time, 20 square roots of 5 would be about what number? Or 20 times the square root of 5. What's the square root of 5 close to? Huh? Probably closer to 2 than 3, right? So if you have 20 times 2, you'd end up with something close to 40. Probably 41, 42, or whatever, but you could say it's approximately 40. Why? Because the square root of 5 has got to be 2 point something. Let me give you one to try, ladies and gentlemen. I can see you're mesmerized by all this. I should probably, what lesson is that? 70 something.
74.
74. Let me find it right out of the proverbial book. How about, let's just do the square root of 18. What is the square root of 18 simplified? I'll give you a second to do that. And again, don't get lazy and not write the radical sign there because you'll find yourself getting things wrong that you shouldn't. Do we get an answer? Ben, move.
Alright. 2 square root of 3.
2 square roots of 3. Let's look at some. So you broke the square root of 18 down into what? Square.
2 and 6. Or no. Oh, I see what I can.
It's not 2 and 6? How about let's go 2 and 9? Or 3 and 6, I guess. You can stop with this. The square root of 9 is the square root of 3 times the square root of 3. So 18 is the square root of 2 times the square root of 3 times the square root of 3. 2 identical square roots of 3 gives you a normal 3, so it's a normal 3. How many folks got 3 times the square root of 2? Now, I suppose it would behoove us, let's jot this down here. Here are the approximations. Remember, these are irrational numbers, so they don't work out, but the square root of 2 is very close to 1.41. The square root of 3 is close to 1.73. The square root of 5 is close to 2.24. And the other one the book says you probably should know is the square root of 10, which would be close to, that'd be 3 point something, what do you think? 3.16. Just so you have that in your notes for whatever reference. Again, remembering these are actually what we call irrational numbers because they would technically be decimals that go on forever, but we round up to these just because who wants to multiply decimals that go on forever? David, do you?
No, I didn't know.
How long would that take you?
I would stop before I know.
You would, or you die before you get an answer because they go on forever. That's just the way it would be. So don't look at me like that. I'm just saying that's a fact. You could not possibly multiply all that because you would have to go forever. Let's see what I look at. All right. Now, with that being said, listen carefully. Here are the instructions. Both things are going to be on Google Classroom. The first one is, I noticed on the last quiz I gave you that many of you missed problems you should not have. So it's going to be a quiz, but you have to get them all right, like whatever. And then after that, there's going to be another thing on Google Classroom that deals with these square roots, which is the same thing. You must get it right before you move on. So they're both things on Google Classroom. And David is saying, do we do it on a different piece of paper? Yes.
No, I was
always.
honest.
Really?
I was
So that's a good, you should have
on a
asked that.
quiz. We all got like a question wrong that we all thought was like
Was
Oh,
that
yeah.
back when? Like 2 days
It was
ago?
like
Number 7.
The one that was 1-6?
It was like 4 point something. 4.76.
I always look back at them. Oh, yeah, well, somebody gave me the paper. Sophia did. Yeah, thank you, Sophia. I will fix that.
Did you post them yet?
I didn't. I'm waiting for a break in the questions so I can get over to the board.
And we did it.
Wait. I should stop recording first.